In this video, we're going to be looking at how to create a spreadsheet for analysing gravitational field strength and weight on other planets and objects in the solar system. And we're also going to create a couple of graphs, one showing the comparison of weight force on the different objects, and the other one is to plot the gravitational field strength versus the ratio of the mass of the object to the radius squared. And from that, we're going to get a straight line, and the straight line should give us the gravitational constant. Let's just do some linear regression so we can see how we get that relationship. So we've got our weight force equation, so mass times G, and that's G at the surface of an object. And then we've got our formula for force, big force, universal gravitational force, where we've got big G, which is the universal constant, and big M is the mass of the large objects, such as the planet, little m, the small objects, such as a person or something orbiting that planet, and then we've got R squared. Okay, so if we equate these two, so if we equate these two, we end up with this relationship. So where we can cancel those out, and then we've got our gravitational field strength is given by big G, big M over R squared. Now, if we want to put that in the form of a straight line and graph it so that we can work out this is our constant. So we can see here that if we plot G on the y-axis, our big G is our constant, and therefore versus our on the x-axis will be this ratio here. Okay, so if we plot our graph like so, we get a straight line, and the gradient will give us this value here. So the first thing to do would be to put all these headings into the spreadsheet. Now this is a field where we're going to put any value here, 60 kilogram person or 100 kilogram, and it will do the calculation of the weight force for us. And this value here should be determined from the straight line graph of G versus big M over R squared. So you're going to have to Google the values that we need. So I found this site here, 9 Planets, will give us the values for the radius and the mass. And the other site was this one here, so BBC Bite Size, but you know, you might be able to find other sources, and just it doesn't matter if the values are slightly out, so it's a process we're looking at, but I'll keep those links there. So I'm just going with the first bit of data. So just format for the numbers, we want them all in scientific notation. So obviously to the 10 to the 30 is quite big, so it makes sense. So just to show you, I'm just gonna click over the whole data and go format, number, and you just choose scientific. So okay, so the calculations we need are the big mass to R squared. So I'm sure you know how to do this. So it's this cell divided by this value, but remember we've got to square it, so we need that little pointy hat. and square it. And then you can fill all the way down. The weight force, now weight force is mass, or little m, times the gravitational field strength equals this mass here of the person, which is going to remain constant, doesn't matter what planet they're on, because mass is constant for that person or thing. So it's that, because we want to make a reference to this cell and keep it at this cell when we drag the formula down, we've got to make sure we hit the function 4 button at the top of the keyboard, or you just include your dollar signs before the row and the column. Okay, so it should equal $C, $3. Okay, so it's an absolute value. Then multiply it using the asterisk times this value here. Now this is a relative reference to the cell to the left of that formula. Okay, and we can fill. So what graph do we want? Well, we want to plot the weight on all the planets and the sun and also on the moon. So we want the whole lot. So on our x-axis we want to plot the planet, and on the y-axis we want the weight force. So we need to click control when we do this. So we've got these selected, then we press the control and then click and drag to select that bit of data there. So then we go insert and chart, and we want a bar chart, and just make sure that we put all our headings and so forth on it. So okay, so celestial objects can include the sun, the moon. Okay, so our horizontal axis title is and vertical we want the weight force. Okay, so it should look like so, and as you put more data in, it will plot the data. Okay, for our second graph, we want to graph gravitational field strength on the vertical axis and the mass to R squared ratio on the horizontal. So this will be our x-axis and this will be our y-axis. So we can select those, go insert chart, and we want a scatter chart. Okay, it should plot a straight line, so we want to get this all ready. So if we go to series, change that to little X marks, trend line, it should be linear, and we want to label, so use equation. Okay, and then it will hopefully give us well, we won't plot until we get some more data in there, because we only got one piece of data so far. Okay, so we can put that here and watch what happens. So once you get the gradient from that, then it can go up into here. Okay, so when you do finish this second graph, you'll probably notice that it's not quite right. So I have to actually remove the sun's data, and I would suggest you need to remove Pluto's data as well, because it puts the values out. The other thing, okay, so if you look at the data sheet for the universal gravitational constant, or big G, you'll notice it gives you 6.67 10 to the minus 11 newtons meter squared per kilogram squared. This is saying 10 to the minus 17, and the reason is because I forgot the radius is in kilograms in the table, so that should have actually been in meters, so that's why that's out. Okay, so the units for this here are based on kilometres, not metres. Okay, so that's why that's out. But this value here, the 6.66 is pretty close to the 6.67 from the data sheet.